Hi friends, welcome back. Today we're talking about inverse functions by composition. So we are going to figure out if two functions are the inverse of each other by using composition functions, which I believe we've talked about in the past. So let's get started on these guys. Okay, the first one that first some notes. To find if two functions are inverses, find the composition of each other. If they both simplify down to x, then they are inverses. I know that just seems like a lot of words that don't really make a whole lot of sense, but hopefully they'll make sense in a minute. So writing it down for right now is a good idea. All right, so here's what we've got. We have f of x is this, g of x is this guy. So what we're going to do is we are going to find g of f of x and f of g of x. So let's start with this. F of g of x. What that means is we're going to take f, and wherever there is an x, we're going to put in parentheses. And you can see that I've already done that here. Okay, so then on our next one, we are going to do g of f of x. We're going to start with g, which we have here, and wherever there's an x, we're going to put parentheses. For both of these, we're going to substitute in. So for this one, wherever those parentheses are, we're going to substitute in g of x, which we have here. Notice that negative is right in the middle of the fraction. Personally, I like to attach my negative to a number so I don't lose it. In fact, I didn't even see the negative when I was practicing this problem earlier, and I got confused as to why I got the right answer or got the wrong answer. So it's a good idea to attach it to a number. So when I rewrite this, I'm going to say, okay, -2 over, whoops, helps if I keep it straight, -2 over x plus 1 minus 2. Okay, so I filled that in with g of x. Over here, I have g. I started with g. Wherever there was an x, I put in parentheses, and I'm going to fill those parentheses with f of x. So I have 2 over -2 minus, or negative x minus 2, all of that minus 1. All right, let's go back and look at f of g of x. Let's do some simplification now. I have a negative on the outside here. I'm going to distribute that negative to here and to here. So I get, so I have 2. We'll say equals 2 over. Okay, so now I'm ready to do that denominator. Distribute that to here and here, I get positive. So 2 over x plus 1, and then negative times a negative is a positive minus 2. All of that minus 1. Okay, so now we can simplify. If you take a look here, I have this guy can cancel out. So I have 2 over 2x, oh, whoops, sorry. Let me try that again. 2 over, that's kind of tricky, x plus 1, all that minus 1. So you'll see that I have a complex fraction here. And what we can do is turn that into a division problem, except we never divide fractions, we multiply by the reciprocal. So what I'm going to say here is 2 times, and I'm going to do the reciprocal of this denominator here, x plus 1 divided by 2. All of that minus 1. Okay, so now I have like 2 over 1, remember we can cross cancel, so I can cancel out that 2, and I'm left with x plus 1 minus 1, and if you see that positive 1, negative 1, those cancel out, and I'm left with x. Excellent, haha, dad jokes, woo! If if two functions are the inverses, find the composition of each other. If both simplify down to x, then they are inverses. So you'll see that this has simplified down to x. Now, that means that we've got this one, but we have to make sure both of them do. So on our next one, we're going to do some simplifying here. We're going to say -2 over, and there's nothing to distribute here, so I'm just going to take it out of those parentheses. And when I do, you see that I get -1 plus 1, all that minus 2. So these guys cancel out. So now what I have is -2 divided by all this garbage here. So instead of dividing, I'm going to multiply by negative x minus 2 over 2, minus 2. Okay, so now what I have is I can cancel these 2's out, but that leaves me with a -1 here. So keep that in mind. We have -1, negative x minus 2 minus 2. So x, now I can distribute that -1 to here and here. I get x plus 2 minus 2, cancel those 2's out, and I end up with x. Since both of these are x, that means that these guys are inverses of each other. So f of x, the inverse of f of x is all this stuff that g of x is. Okay, let's try some others. So for this guy, we have f of n and g of n. Now we're going to start with f of n. So we're going to start with f, and wherever there's an n, we're going to put in parentheses, just like that. And for g, we're going to do the same thing. We're going to put in parentheses wherever there is an n. Now for this one, we're going to fill our parentheses with g, which is negative n minus 1. And this one, we're going to fill our parentheses with f, which is negative 9 n minus 4. Okay, now we're ready to simplify. So over here, I'm going to distribute this to here and to here. So I get 9n plus 9 minus 4. Okay, so that gives me 9n plus 5. That is not n, so this is not the inverse. But let's go ahead and finish this so you can see. I'm going to distribute my negative to here and to here. So I get 9n plus 4 minus 1. So for this one, I get 9n plus 3. Okay, so now that we see this, these are not inverses of each other. Hopefully that helps. If you have any questions, let your teacher know, and we'll see you next time.